Hello, my name is Beth Dixon, and we are doing a Math 1830 review, and there's some chapters that you need to review before you're able to do Calculus A. So let's just begin. When we do this, we're starting with chapter 0 in your textbook, section 1. So this is 0.1. The first thing we need to know is the meaning of the following symbols. The first symbol looks like an upside down U. The second symbol looks like a U. The third symbol looks like a funky E. And the last symbol is a 0 with a line through it. Lots of people make their zeros this way, and I do not like that because the 0 with a line through it has a special meaning in math. So let's start with these symbols. And I don't know how Miss Moneyham put these on there, but apparently these two symbols are joined together because when I move them around, they stay together. So we're going to go through those symbols. The first one is intersection. So this first symbol is intersection. And it is the intersection of two sets. A set is a group of numbers or items or data information, and that means that we have a set, and we can have in that set, and actually we should start, I'm not sure she did it this way, but let's back up just a second, and let's start with this symbol here. And that symbol here, when I draw it, tends to look like this, kind of a C with a line through it that makes it look like an E. And this means an element of. And that's something that's a member of a set. So if I have the set of people who are in my class, so I'm going to list the people who are in my class. So if I did that, there would be nobody in my class because I'm taping to an empty room. But in this case, let's pretend that there are people in my class, and let's pretend that I have in my class Tim, Bob, Pat, and Ann. And those are the people in my class. So that's the set of people in my class. And then I can make the statement that Tim is an element, and I'm going to call my set C for class. So Tim is an element of my set of C. Oh, I don't know what I hit. The board is really sensitive, so I went off in Neverland. Sorry for that. So now I have that Tim is an element of C. It means it's a member of a set, an element of, or a member of a set. So we want to start with that one. Now we're going to go to intersection and union. Now, how do you remember which symbol is which? Well, I remember because I can't use the ends because they both really have ends, so I kind of have to do something a little different. But I remember union is the U, and this one kind of looks like an N. So I think of it as intersection. I have to be careful because there's an N in union, but if I can't use the first letter, I go to the second letter. Well, I can use the first letter there. So N sounds like an N, so I make it look like an N. Union starts with a U, I make it a U. It works for me. If it doesn't work for you, then we'll need to come up with another method. But that's the two words. So when we look at two different sets, we can combine them with these two words, one of these two words. And if we look at three sets, we can use these two words together, or we can use these two words in intersection of two, or the other. We can do a lot of different things. So how are we going to start here? With the word intersection, we're going to look at union. We're going to look at a road. So imagine a road, and we think of the word intersection like an intersection of a road. Okay? If I have two roads, and let's call one road Main Street, and one road Elm Street. And I'm going to change, and I'm going to make Elm Street green, and I'm going to make Main Street red. Now, if I have Elm Street and I want to know where it intersects, you're supposed to stop me. I'm not supposed to have two Elm Streets. I'm supposed to have one Elm Street and one Main Street. If I have Elm Street is this road right here. And if I have Main Street, that is this road right here. But if I want to know where they intersect, where they cross here. That is where the road of Elm and the road of Main are both true. If I were standing in this intersection, I would be on Elm Street and on Main Street at the same time. So the intersection are those elements that are in both sets. A union of Elm and Main would be all of Elm and all of Main. So when I look at it, it would be all of this area and all of this area joined together. So this is the union, and this is the intersection. So when I look at that, notice the union joins two parts, and everything in one and everything in the other are joined together, and they're both part of my answer. If I'm talking about the intersection, it's the part where they cross, where both parts are true at the same time, what they share. Notice if I call the ambulance and I'm standing on Main and Elm, it's where I'm both on the Main and Elm at the same time. So it's inside that box. The ambulance is going to be able to find me. They're going to go there. It's a smaller area and they can find me. If I'm talking about over here, I'm talking about all of this area, and I can move this in and do it, but it's all, oh, I like that. It's all of this area right here, everything. So if I'm standing anywhere here and the ambulance is looking for me, they've got a lot more area to cover to find me. I might die of my heart attack before they find me if I'm on this, either on the union of those. Now, let's look at an example of this. Let's say we have a class, and in this class, let's say it's a calculus class. So in a calculus class, I have the students Tim, Bob, Pat, and Ann. And in an psychology class, whoops, that's supposed to be a P. Can't spell psychology today. In a psychology class, I have the students Mary, Lon, Bob, and Ann. So if I have those two, then what I can do is I can talk about either the intersection or the union of these two groups. So let's take the group C union P, and it looks like the word puff. I did not plan that. So, but it's C union P, so that means I want all of this and I want to join it. We want to join the two groups. So it's all of C plus all of P. So that would be everybody that's in both groups. So that would be Tim, Bob, Pat, Ann, Mary, Lon, Bob's already listed and Ann's already listed, so I don't have to list them twice, and that's everybody. If I have C intersection P, that would be the students that are taking both psychology and calculus at the same, or that are taking both of those classes. Well, those would be the ones that are in both, and that would just be Bob and Ann, as those are the only two that repeat in both groups. And that is your definition of union and intersection. So we talked about from here, we talked about what this symbol means, which is intersection. This symbol is union. This is your symbol for element. And the last one there that we have is the symbol for empty set. So this is the symbol for empty set. And what is the empty set? The empty set, I'm going to call Beth's class today. Beth's class today, as she is videotaping this for you, is the empty set, which means there is no one in this. It is not the same as 0. It means there is nothing in this set. Okay, next we have set builder notation. Set builder notation is the notation that you will find in your textbook and on your web assign as you do your homework, and it is often found in your answer keys. It is not necessary that you use this answer unless your teacher instructs you to do so, but you will find it. It is very mathematical in its design, and lots of math majors will have to use it. So why are we covering it in a review section? Well, you won't have to use it, but you do need to be able to read it to check your answers. Set builder notation is building your answer with the use of sets. A set is always listed in these braces. So we make our braces. Then it tells you which variable you're going to use. In this case, it tells you that you're going to use x. If I were making it in y, I would write y. If I were using the variable z, I would then write z. So whichever variable I want to use next. Then once I've written my variable, I write this little bar here. That bar means such that. That bar is a symbol for the word such that. Mathematicians, personal opinion, mathematicians don't like to use a lot of words, so they use symbols. And as they use symbols, they come up with lots of symbols to make words. So this is saying the set of numbers where x is my variable, such that, and then the next part tells me what the answer is, where the x's are greater than 3. So this is all the numbers where x is greater than 3. If we were solving the problem, we probably would have gotten this answer here as our answer, so that x is greater than 3. The answer in the back of the book would have looked like this, and we're saying, well, we didn't get that, but this matches this part, so we're good. Okay? We're going to look at some examples and read them out loud and then complete it whether it's true or false. So is -5 an element of the set of all integers? Well, we've got to then decide if it's true or false. The set of all integers are 0, 1, 2, 3, 4, 5, 6, counting up, and then the opposite of those numbers, they can only be the whole numbers, zeros, and their opposites. So -5 would be the opposite of a +5, therefore it is an integer, and it is a member of that set, therefore that is true. Blue is an element of the set of colors red, black, and green. Well, let's say we have a flag. It's red, black, and green. Is blue a color on that flag? Well, if the only colors on that flag are red, black, and green, blue is not a color of that. So that is false. So now we have the set of two numbers, and we're going to find the union of that set. So the first set is the numbers 1, 2, 3, 4, 5. And the second set is the numbers 2, 4, 6, 8, and 10. And we want to find the union of those numbers. So we want to make it, and when we do this, remember I said sets go into your braces. And so the union means to join. And so what are we going to do? Well, what I generally do is go 1, 2, 3, 4, 5, which means I copy down the first set. Then I go to the second set and say, oh, 2's already there, 4's already there, 6 is not, so let me write down 6. So now I've got the 6. 8 is not, so let me write down the 8. And then 10 is not, so let me write down the 10, and that takes care of all my numbers. Yes, I checked them off, but I also checked them off so you can see the order in which I did them. And that is the union of those two numbers. Next, we have the union of two set builder notations. Or excuse me, the intersection. That's an upside down U or something that looks more like an N. So first of all, we want to remember that this is the intersection. So this is where they cross, not to join. So this is where they cross. Another word that we use here is overlap. So this is where they overlap. And so in this case, I would never do this in my head. I would do this with a graph. And again, the set builder notation just says the set of all x's such that x is less than 5. So ignoring all of this and this, I'm looking at this statement right here, and I'm going to draw a number line. Boy, does that not sound good. Okay. So I'm going to draw a number line. I'm dealing with the number 5 over here. I'm dealing with the number 2. So I'm going to put my 0 down here. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. I'm going to put a 6 just so I know which direction I'm going. Then I'm going to do each of these in a different color so I can see. So I'm going to do this one in blue. So that is x is less than 5. Because it's not equal to, that will be an open circle or a parenthesis. So we start at 5, and we'll have an open circle, and it's less than, so it will shade to the left. Now that can be on top of the line, but to be clear on my computer, I am going to draw that above the line, so it's very clear where I'm shading. Generally, that would be on the line itself. Let me write you a little note here that less than and greater than do not have equals, so they get an open circle through the number line, and they get parentheses either to the left or right parentheses, and these are called your open intervals. Your closed intervals are those that have the equal to, which would be less than or equal to, greater than or equal to. When we draw those on a number line, they get the solid filled in dots, and they get the brackets. We will cover that again when we cover interval notation, but we need to go on and mention that here. Now, in a video, you need to write that down. You'll want to pause, but in the magic of computer and live video, I'm going to erase that so that I can write. Now I'm going to do the second part, which again, I ignore this part, I ignore this part, and just look at that part, which this one starts at 2. It is greater than or equal to, and so therefore I'm going to do a solid circle at 2 and shade in this direction. The only thing I wish I had was a purple marker. On my smartboard, I do not have a purple marker, but where do red and blue make purple would be what I would say. So where do the red and blue cross? Well, red and blue don't make green, but if I were doing it in line, I would get out a purple and show you that this is where they overlap, where both of these would be shaded. Where are we here? We're shaded here. And I would have an open circle here and a closed circle here. And so when I write my answer, I would start with the set builder notation. If I were checking it in the book, if you're writing your answer, you can probably leave that out, but I would start with the set builder notation because it has set builder notation. What is that? That's the x such that, and then my x here. Because we have a start and a beginning, that means I'm going to have an x, and I'm going to go from the smallest to the largest of the numbers. And I need to make the one on the left here is a solid dot, so that needs to be equal to. This one's an open and does not, and it does go from 2 to 5, so that goes 2 to 5. So it's saying x is less than 5 and greater than 2, and it limits me to this area that's in the green, and that would be your answer. Sorry about all that jumping around. I was trying to arrow down. Okay, let's look at the next question. Is zero, the set of 0 equal to the empty set? No. Now, if I say there is no one in my class, that is, let's make sure this is false. If I say the number of people in, let me say this where I can say it's true. If I have the number, let's call it not C, let's go back to N. Okay, I have the number of students in certain classes. So the number of students in classes, I have a class with 0 students in it, I have a class with 5 students in it, I have a class that does not look like 5, that looks like 6. So I have a class with 0, I have a class with 1, I have a class with 5 students, I have a class with 25 students. And that would, maybe those are the sections of the online classes that I'm teaching. And that's the number of students I have in each of those sections. So that would be 0 would be an element of this. Now, let's say I had a set where 0, let's not call it N, let's say I have the ages of babies in my church nursery. And we'll call it A for ages, to use a different variable here. And so the ages would be, and let's say I only have one baby and all the babies are 0 years old. And so 0, therefore, is not an empty set because that 0 represents the ages of babies. So that is not empty. Let's say I have the number of classes that Beth teaches. That is the empty set. Well, I should write it correctly. That would be the list of classes Beth teaches, which is blank, and that is considered the empty set. There is a difference between A and this bottom N. Let's call it C, so we're not getting confused. I keep wanting to go back to that N. I just like N today. A is 0 and C is empty. The number of classes I teach is empty. I don't have any. Yes, that's none, but here the ages are 0, and that is something, even though it's 0. What if I was measuring the number of defects that your business produced and the number of defects or the number of complaints that your business had over the month, and that number of complaints was 0? That is not the empty set. That is an answer and a member of the set. So if you have 0, it is not the empty set because there is something in the empty set. Okay, as we conclude section 1, remember you have practice from the textbook that you will need to complete. That is on page 7, problems 1, 3, 23, 24, 27, and 28. And please complete those and then move on to section 0.2.